How do I solve equations with x squared? Comments?
No.
How do I solve equations with x squared? We're going to do a lot of review and a little bit of new. First thing, if you don't have a perfect square, then you're going to have to put the square root in your calculator. Here's how we do that. Here's a reminder. You will see the square root button. It looks like this. You're going to see that over the x squared button. To get it, you have to press second x squared. Okay. 121. 121 is a perfect square, so what's my square root? 11. Do not put it in your calculator, you know it. Francesca, do you see another perfect square?
-9.
Yet that negative square root of 9, there is a perfect square there. So Francesca, what's the square root of 9?
-3.
Hold on, what's just the 9? What's the square root of 9?
Oh, 3.
3. And so what ends up happening here is this is a -1 times the square root of 9. So we write that as -1 times 3, which is -3. Olivia, do you see any more perfect squares?
Square root of -25.
25 is a perfect square. Does someone see a problem with what we have right now? Jovia, go ahead.
Doesn't the negative, the subtraction sign need to be on the other side?
Right. And so what we say for this is that it's, we could say not possible. Because the negative's on the inside, we can't do it. So it would not be -5 because the negative sign is on the inside. Into the square root of, because it's a fraction, square root of 256 over the square root of 81. I know that the square root of 81 is what, guys? 9. Okay. So 9 goes on the bottom. In your calculator, can you please figure out, and don't say it yet, please type in the square root of 256 and figure out what it is. If I type it in my calculator, I get 16. This is how you should leave your answer as a fraction. The answer to this is 16 over 9.
Not simplified.
So up here, I got 2.75. Does someone have the square root of 67 for me? Raise your hand. Tyler, go ahead.
8.19.
Did you have to round?
Yeah.
Okay, so we're going to say approximately 8.19. Oh, whoops, I don't have it up on the screen. I'm actually going to change this one to 8.2. Here we go. Next, what makes a number rational or irrational? We haven't talked about that in a while. Rational numbers, remember, are like normal people. Rational people are regular. They're not crazy. Rational numbers can be written as a fraction. That was our definition. And they are normal. Whole numbers, integers, fractions, decimals that stop, decimals that repeat. Those are all rational numbers. And then we talked about irrational numbers are crazy. And they go on forever and ever, and they never repeat. Never repeat. That's important. Let's decide based on what we got when we evaluated if it's rational or irrational. Okay. Yeah, we're just going to do R or I. The square root of 121 is equal to 11. Pretty normal, right?
Yeah.
It's a normal number. It's a whole number. And so we're going to say that it's rational. There's nothing weird about that. We're going to put an R down here.
Rational.
For rational.
Wait.
It could be written as a fraction, 11 over 1. Next one, 7.5625. And hold on. We got 2.75. Here's what we need to know. 5 is rational because it does not go on forever. Because it does not go on forever, it's rational. Just because it's a decimal does not mean that it's automatically irrational. Okay. No, okay.
She just hit me in my.
And so we say it is irrational. That's a crazy number. We end up having to round it up. Jawan, negative square root of 9. Rational or irrational?
Rational.
How do you know?
Because it doesn't stop. I mean, it stops.
You get negative 3. Is negative 3 a crazy number? No, it's normal. It's called an integer, and so it's rational. The square root of negative 25, well, we couldn't even do that one, so we're not going to do that. And then the last one here, square root of 256 over 81, we got 16 over 9, which is a fraction.
Rational.
Fractions are always rational. Okay. We're going to solve the one-step equations at the top, which is review. We're undoing with inverse operations. So this first one, guys, how do I undo subtraction? Say it out loud. Addition. So I end up getting x is equal to 74 plus 7, which is 81.
81.
This is addition because there's a positive number out front. If I want to get rid of the 19, I'm going to subtract it. Is this 62? 64. 64. X would be equal to 64. Now, the next question is what happens when we change x to x squared? That's what's new today. So we're going to solve it the same way we started before. We're going to add 7. You should not be talking right now. And I get, instead of x, I bring down what's left. What's left is an x squared. Remember that squared tells me how many times to multiply the x. That's the same thing as x times x is equal to 81. So two of the same things together equal 81. We just reviewed this right before we started.
So it just equals 81.
Would someone please tell me what are the, if I multiply the same number twice, what number would have to go there for x? Raise your hand.
1.
Raise your hand. Jovi.
Perfect square.
81 is a perfect square.
Oh, so it would be 9 times 9.
Okay. 9 times 9 is 81. So x would have to be 9. Or it could also be negative 9. Because negative 9 times negative 9 is also 81.
Oh yeah, because like negative times a negative.
So if the x changes to an x squared, then you got to figure out what number multiplies by itself twice to get you the bigger number. One more. Okay, we'll start the same way. This is the same one as the top. Subtract 19. X squared is equal to 64. And so I want to know what x is going to be. Because it's x squared, it has to be x times x is equal to 64. X times x is 64, so square root of 64 is 8. So x could be 8, or it could be negative 8. Long day. Undo the addition or subtraction. And then we're going to take the square root. Last two, make sure your voices are off so you hear me. We're solving an equation. So we're going to draw a line down the equal sign. I have to undo my addition or subtraction. I see subtraction. So Riley, what do I have to do to get rid of the minus 42?
Add 42.
Yep. I'm adding 42. We're going to solve it like we've done for 6 weeks. Are you with me? Your voice is off.
What I know.
Cross out that because we canceled it out. And we bring down what's left. X squared is equal to 92.
Yep.
Okay, the problem with this right now is that x is not by itself, and 92 is not a perfect square, so you can't do it in your head.
So you just.
It's irrational.
So here's what we got to do. The opposite of squaring something is taking the square root. So I'm going to take the square root of both sides because it's an equation. And your answer is going to be whatever the square root of 92 is. So you'd have to type in your calculator square root of 92. It's probably going to give you a decimal, and then you need to round to the nearest tenth. So I get about 9.6, but because I'm rounding, I'm going to do this weird equal sign. Because I'm saying it's about 9.6. There's actually one more answer to this. Olivia, what is it? Negative 9.6 also works because negative times a negative is a positive. So you need to make sure that you write both answers, and if you round, you do that weird equal sign. Because it's not exactly 9.6, it's about 9.6. Janiyah, how do I get rid of addition? Okay, so minus 246. That goes away. I'm left with x squared is equal to 54. I'm telling you, subtraction is where I'm the weakest. The opposite of squaring something is taking the square root. We're going to do that together, okay, class? So here's what I'm going to ask you. I'm going to say, what's the opposite of squared? And you're going to say square root. Okay. Class, what's the opposite of squared?
Square root.
So if I want to get rid of a squared, I have to do the inverse. That's the fancy term we used. And do the opposite. So I have to take the square root to get rid of the squared. So my answer is going to be whatever the square root of 54 is. Put square root of 54 in your calculator. Since you rounded, you have to put the squiggly equal sign. Positive 7.3 or negative 7.3 are your answers. Both irrational. Because they were crazy and they went on forever and they didn't repeat. And they weren't whole numbers.